Hi everybody, so right now we're gonna review chapter 7.2, 7.3. So I just circle what I think it's important, especially as you review for your exam. So let's start with number 3. It says find the p-value for the indicated hypothesis test with a given test statistic. So they gave you the z-stat. Decide whether to reject or no for the given level of significance. So it's a right tail test. We know it's going to be on the right. Okay, and then they say the z statistic is 1.78. That's your z stat. And then they give you an alpha of 0.03. So if you find the p-value, that's the probability to the right of that z stat. So anything that's going to be greater. All right, so we're looking at this area here. So we're doing normal CDF from 1.78 all the way to a big number or infinity. Okay, of course, by default, we know that the mean is going to be 0, standard deviation 1. So when you plug that in the calculator, we go on the DISTR. So turn on. We go on the second function, second function DISTR, normal CDF, 1.78. We go to 10,000 or 1,000 or even 4. That should do it. So this is our answer. So our p-value is a 0.037, and that is greater than your alpha, which is 0.03. So we're going to fail to reject. It says round to 4 decimal places. We're going to fail to reject or null, since the p-value is greater than alpha. So this is one example. That's a freebie. 4, you can do it on your own. 5, you can do it on your own. 6, let me see if I can do something else that's close to that 6. Let's do 7. A random sample of 81 National Mathematics Assessment Test with a mean score 273. Declare that is more than, so HOHA mean is more than 270. So this guy is going to be the inverse. There is your claim. Standard population, standard deviation, they give you sigma at 32. Your n is at least 30. So this is a one sample z-test. It says write the claim mathematically. All right, so it's more than. There goes the claim. So this, your choice should be D. What's the z-stat? We're just going to plug this in the calculator. It's a p-value method. We're going to plug in all of that information in the calculator. So under stat test, you go to z-test. I'm going to show you my setup. My mean 0 is 270, hypothesized mean. Population standard deviation is 32. X bar is 273. N is 81. So you have summary statistic and it's a more than. All right. So there goes our setup. This is how you set up. And then you calculate. Once you calculate, this is what we get. And this gives you everything. It gives you the p-value. It gives you the z-stat. It gives you everything you might possibly need. So the z-stat is here 0.84. The p-value is 0.199. So it's a big p-value. Your alpha was 0.11. So it's greater. Failed to reject since p-value is greater than alpha. Okay. How do we interpret the decision? Remember, the claim was in the alternative. So at 11% significance, there is not. There's not enough evidence to support the claim. Yeah, that the mean is more than. So this is something that I did in less than 30 seconds. You ought to be able to do such a thing as well. This is a lot of data. 30 points, I can't. Let me see if this is a 2, no more than. That is the null hypothesis. No more than, so it has to be no more than, it has to be less or equal to. Mean is less or equal to 922. So HA is going to be mu less than 922. I'm not doing it. You can do it on your own. This is a left tail test. It's a right tail test again. So I don't need to do it. No more than. It's a right tail test. I don't need to do it. And your claim is in the no. I'm not going to do that. Y'all do it on your own. This is still 30. That's a lot. I'm going to try to find a problem where I can do a test. I don't have 30 data points. Well, let's do this. A weight loss program claims that program participants lose at least 10 pounds. So at least 10 pounds. Mu has to be at least 10 pounds. Means greater or equal to 10. This is it, at least. But your claim is here. You have n equal 30, alpha 0.08. They gave you the population standard deviation to be 3. So they gave you data. So literally we have to go into stat edit and we enter the data in L4, wherever you want to enter the data, but go ahead and try to enter data without making any mistakes. It's not easy, but try to enter the data as quickly as you can without making a mistake. I'm doing it because we have less than let's see, 7.4, 9.6, then 12, 12.7, 10.4, 10.7, then 10.9, 15.4. All right, so just checking really quickly. Just making sure I didn't make a mistake. Just making sure I did not make a mistake. All right, so my data is in. So this is what I have. It's a less than. So this is the choice, it's F. Find the critical value. It's a less than sign. So because it's less than, it's a z-test. So negative z, so alpha is 0.08. So this should be inverse norm, 0.08. So second function DISTR, inverse norm, 0.08. So this is my setup. Okay. Paste. So this is what I get. For my critical value. So the critical value is negative 1.41. It's going to be on the left side. So there's probably another choice somewhere here that is choice C. That looks exactly like my graph. So the choice should be C here. What's the standardized test statistic? So stat test, z-test. My data, I have data, I don't have stats. Mu0 is 10. Sigma is what, 3? My list, I think, is L5. If I'm not mistaken. So less than. Okay, let's see. Oh, it's L4. All right, I'll show you my setup. This is the setup. And then calculate. So here's what I get. So my Z statistic is negative 0.42. So the question is, does it fall? This was negative 1.41. Does it fall in the rejection region? No, it doesn't. Z is not in the rejection region, so we failed to reject the null. Yep. Look, your negative 0.42 is somewhere here. So it's not in the rejection region. So at the 8%, there is not enough evidence to reject the program's claim that program participants have a mean weight loss greater than or equal to 10. All right, so this is it. Make sure you can do something like that. Pause the video, watch how I work it out. This is a left tail test. It says left tail test alpha and it's a T. So like so, left tail alpha is 0.025 and is 21, so degree of freedom is 20. So if it's a t, you want the critical t, you do inverse t, 0.025, comma 20, your degree of freedom. On the stat distribution, on the distribution, you're going to see inverse t. I'm going to set it up and show you the setup. All right. So here it goes. There goes your critical value. Okay. So my critical value, I only have one, negative 2.086. That's it. So t is less than. So it should be B, the answer. T is less than negative 2.086. That's that. That's what you plug in here. All right. Those are quickies you ought to know how to do. Now this one is actually pretty nice. It says state whether the standardized statistics, so t-stat, indicate you should reject a null or fail to reject a null. So here, from what I understand, it's a left tail test, and your critical is negative 2.181. So the first one is t is 2.255. All right, so t is 2.255. So it's not in the rejection region. So we're going to fail to reject because t is greater. Do you all see that? That's how we do it. Now the next one is t equal to 0. It's still not in the rejection region. We fail to reject because t is greater than. Hope everybody sees that. Okay. Now t is negative 2.105. 2.10. So could be somewhere here. It's still not in the rejection region. It's still greater. All right. And finally, t is negative 2. T is negative 2.239. So somewhere there. Finally, it's in the rejection region, and it's less than. So here we go. This is a freebie that I particularly like. Take a deep breath wherever you are, so we can continue working. 3, 2, 1. I'm not going to do 13 because I'm going to do something else. Let's see. I'm going to do 15. It says test a claim that the mean amount is less than. This is the claim. This is definitely the alternative. The null is going to be mu. All right. It was found that the mean x bar is 2.39, n is 65, standard deviation is 2.1, at alpha equals 0.11. Assume population is normally distributed. So this is a t-test, one sample t-test. So let's start. Mu is going to be then 2.33. Mu less than 2.33. The claim is in the alternative hypothesis. Critical value, this is a less than sign. Probably is going to be less than sign. We're going to find a critical value in a minute, but it looks like this for sure. So alpha is here. Alpha was what? 0.05. All right, so inverse T, 0.05, degree of freedom is what? 64. Inverse T, 0.05, degree of freedom 64. Paste. Let's go. So here goes the critical value, negative 1.67. The standardized test statistic, we go on the stat, test, t-test. You're going to enter our stats. Mu0 is 2.33. X bar is 2.39. S of x is 2.11. N is what? 65. Okay, so we do less than sign. I'll show you my setup. Press enter to get the results. All right, here's our results. The t-test. All right, so the t-test is t-stat, round to 2 decimal places, 0.23. Decide whether to reject or fail to reject the null. I'm going to fail to reject the null. Why? Look at the p-value, it's big. So we are going to fail to reject the null for sure. So fail to reject. Fail to reject the null because the standardized test statistics is not in the rejection region. There is not enough evidence at the, how many percent? At the 5% level of significance to, I'm going to say, support the claim that the mean is less than less than 2.33. All right, make sure you know how to perform a t-test. On the calculator, interpret the results. See, p-value, t-stat, deviation, sample mean. You can do 16 on your own. Maybe I'll do one more. That's it. This is the p-value method. You have data. So we're going to go into stat edit and enter data in L. I'm going to enter mine in L4. So stat edit. I'm going to enter my data in first. So now you have the data. It says the dean of a university estimates that the mean number of classroom per week for full-time faculty is. So this is the no. The alternative would be different. As a member of the student council, you want to test this claim. A random sample of numbers, number of classroom hours for 8 for 1 week is shown in the table. Alpha equals 0.01. Complete the part. We already know is less, is equal or different. Yes. Now the next thing is, what is the p-value? Since we already have the data in, our life becomes pretty easy. So you're going to start test, t-test, data. I'm going to show you my setup. Here it goes. Let's crop. Here we go. Press calculate, shoot, test, t-test. All right. Here we go. So my p-value is here. The p-value is 0.165. Now we compare it to alpha. This p-value is greater than alpha, which was 0.01. So we're going to fail to reject the null because p-value is greater than the significance level. So where was the alternative? The null was the claim, and we failed to reject the claim. So it means that at 1%, there is not sufficient evidence to reject the claim, yeah? At the one, there's not sufficient evidence to reject the claim that the mean number is less. No, not less than. That's not right. It's not A, it's not C. It has to be something here, because what messed this guy up is the less than. It shouldn't be. So I'm thinking the key says D is the answer. All right, that's it. That's it for my review. The rest you could do, the keys right here. You can do on your own. I just wanted to make sure that you guys know what to do. Please go back and redo what I highlighted. Go back and redo what I highlighted for the exams to come. Go back, redo, and try the rest on your own. Make sure you complete it on my Start Lab. Okay? Have a great evening, everybody. Bye-bye.